phase. So, the Keysight IntegraVision Power Analyzer is a single instrument that allows engineers to see what's happening because they can see the waveforms, to measure what's happening, and that's this blue box here gives them all the measurements on their AC power, now for three-phase, and therefore to prove the performance of their designs. It's a highly accurate family of instruments with 0.05% basic accuracy and 16-bit resolution. If we compare that to an oscilloscope would have about 1% accuracy and 8 to 12 bits of resolution. So we're talking about something that's about 100 times more accurate than an oscilloscope for making these kinds of measurements. It allows the engineers to visualize transient and inrush and state changes with a high-speed digitizer of 5 megasamples per second. And it allows engineers to view things in real time or in the frequency domain when they want to look at harmonic content of the AC signal. And that's important when you're concerned about the quality of the power that you're generating. It has a 300 millimeter touchscreen, as well as USB on the front for storing information. So the new version, the PA2203, is designed for R&D engineers who are building electronic power conversion systems. What we mean are AC to DC power supplies, like you would have to charge up your computer that plugs into the wall AC and puts out DC to charge the laptop. A DC to DC converter. This would be useful in a car, where the car battery could be 120 volts, but many of the subsystems within a car run on 12 volts. So there would be a 120 volt to 12 volt DC to DC converter. Or it could be used for DC to AC inverters. In this case, there's a picture of one here. This is a solar inverter that takes DC power from solar panels and converts it to AC power to run a home or a small business. So we call that a DC-AC inverter. This box here is probably about this big and sits on the side of a building and produces probably about 15 kilowatts of power. So the key applications for a three-phase power analyzer is for testing grid-connected devices like inverters and power distribution units. It can analyze three-phase motors like you would find in an electric vehicle. Other high-power devices, aircraft and satellite power systems are all run off of AC. Lighting systems, electronic ballast. These lights I can see, for example, are LED lights. LEDs are run off of DC power, but the energy coming to them is AC, just like you would have in any other building. So there's a small AC to DC converter in each of these lighting systems. And of course, battery chargers, electric vehicles, and hybrid electric vehicles are all examples of high-power three-phase AC. These engineers who are designing these systems need to make power and efficiency measurements on their devices in order to determine if they're making improvements and using energy more efficiently.